Okay, we'll continue with the pitfalls of source code auditing. Very fun topic. Okay, enjoy.
Yeah, hello. Am I good understood everywhere? Yeah, great. Yeah, welcome to our talk about circumventing common pitfalls when auditing source code for security vulnerabilities. My name is Alyosha Jutmeier and I'm working as a security consultant for SecConsult. And I also would like to introduce my dear colleague, David White, our lead developer at SecConsult. And today we're going to talk about the subject area of security source code review. But first of all, I would like to ask you some questions to get to know my audience a little bit better. Please raise your hands if you're in some kind working in the software development, for example, as a developer, software tester, software architect, or in the software buying department. So please raise your hands. Okay, yeah, quite a few. Okay, now if you're doing source code review in your company on a regular basis, and by source code review, I mean a dedicated time frame where your developers are looking at code they haven't self-produced, please raise your hands now. Okay, about 4, yeah. Was kind of expecting that. And now please raise your hands if you're doing threat modeling for software, for example, as an external consultant or in the software development. So please raise your hands now. Yeah, even more. Yeah, great. Okay, thank you very much. This was the warm-up part for today. So, and now to our agenda. The agenda is pretty straightforward. First of all, we talk about some common pitfalls and the awful truths about information security. That's where we present some facts that should be but aren't often obvious. And then we will wrap up with a discussion about some tool-based approaches that can help to eliminate some security problems. Yeah, the awful truths, or more or less stating the obvious. These are not particularly new or earth-shattering facts, but they tend to get forgotten over time. So let's go to the list. Number 1. Magical thinking obscures rational evaluation of security features. So this basically means that there are no magical security solutions that can solve all your security problems. There is basically no such thing. Number 2, many vendors, not all vendors, of security products suffer from pathological optimism. So, or maybe they simply don't tell the full story. Number 3, security is seldom considered during software development. So just by having the right tools at hand, this doesn't mean you don't need a proper software development lifecycle. And tools are useful, but only in the hand of experts. Even if you got the right tools, you have to check or verify manually the output of the tools, and you always have to do the correction manually, so this can't be replaced by tools. And number 5, security solutions rarely prevent developers from making the same mistakes over and over again. So the developers are left behind by a lot of security solutions, which is a problem because they in fact have to fix the problems. So let's go a little bit into detail about that. First of all, magical thinking. What do I mean by magical thinking? I mean some kind of totemic power that makes insecure things secure, but this doesn't exist. And why is this? Because security sometimes refers to security features. What are security features? Security features could be anything. That could be an appliance, that could be a scanner, that could be a software or framework, or it could be the use of cryptography. But what's the problem? There are exist these security paradigms that just by putting something like that or buying something like that and put into place, turn it on, you don't achieve security. And there's a nice comparison when you look at on this gate here, on this border. When you take a little closer look on such things, you see that in most cases in reality such default measures are easily circumvented. So there is a difference between security features and secure features. The one thing is something that can help you with security, and the other thing is the secure implementation of functionality and business logic. So in the one case, you are robust by design. This means there's a difference from protecting, buying a tool or something like that that tries to protect from the OWASP top 10 vulnerabilities and having all developers that are lead and expert in their area of knowledge. So number 2, yeah, some vendors, not all of them, do not tell the full story. I advise you to grab a flyer, get informed, and make up your own mind about statements like that. Can do everything. So that's the quote. But I wouldn't want to go. Yeah.
Can you give some examples?
No, just get informed. No, grab some flyers and make up your own mind. I advise you to do that. So security is seldom considered important during software development. Even nowadays. It's true even nowadays. That's what we should know already. Vulnerabilities that are found late in the software development cycle cost more to fix. That's a fact. Gartner says it's up to 25 times more. So the logical consequences would be to fix them early and to invest in quality assurance and testing. But sometimes this is not the case. And as a result, if the errors are found in late stages, they won't get fixed because it's too expensive. They hope nobody finds them. So you may argue that when we talk about errors that are not there, this could be everything. This doesn't have to be security relevant. So what is a security problem? If you go back to the basic principle of informatics, input, process, output, in German, Eingabe, Verarbeitung, Ausgabe. Security problem is something that affects the output, the processing, or the input in a negative way according to confidentiality, integrity, and availability. So it could be more than you might guess at first place. For example, a big German bank, not even a year ago, was in the news because some of their customers of the online banking became billionaires overnight. The reason for that was a software bug, and due to the fact that their balance was 92 billion euro, there's a nice theory about what this bug might be. If you're looking at a signed integer, 64-bit signed integer, it can hold, when you express it in euro, about 92 billion euro. That's because the last 2 digits are considered a cent. And the binary representation of that value would be 64 times a 1. So what else would be 64 times a 1? In the 2's complement, -1 would also be in binary 64 times 1. So the theory is a method which shouldn't return -1, which was then interpreted as 92 billion euros, which is quite a difference, having a balance of -1 and 92 million euros. So even such small things could lead to big problems. And method returning -1, this is a small integrity issue, but can lead to big problems. So you really don't know in advance what's going to be a big problem afterwards. Yeah, how do we get secure software? I think this is one basic model of a software development lifecycle. I know there are a lot of different models and there are a lot of different approaches. This is just one basic model. More or less, they all consist of the same steps. You got a planning phase first, then you got the design phase, some implementation steps, of course some testing and acceptance. Testing would be also a good idea, and if you're done, you're going to deploy it, and maybe there's also some compliance checking afterwards. So what's the issue here? It's a fact that software changes over time. So you have to consider in such a model that maybe you have to step back once. For example, if you're finding a major error during your implementation phase that forces you to do some reconstruction, some design reconstruction, you have to go back. This should be possible. And the other thing is you have to find such errors. So you need here this assurance or risk management processes that are working in parallel to your development phase. The focus of this talk is not really software maturity models, so I just will go into detail a little bit on reviewing and threat modeling and risk management, because I think these three things are very vital for software security. So let's skip that. What do I mean by when I'm saying threat modeling? Basically, I mean something like this. So diagram of your software architecture or the whole architecture, because nowadays software isn't independent of other components. A lot of software is part of a multi-tier architecture, so it's always communicating somewhere, somehow. So what are you doing with threat modeling? First of all, there is no rules for design you have to follow. It's not like UML. It could be very informal. It could, for example, start like this, just a drawing of your architecture, and then you're considering threats to this architecture. Here in this example, for example, cross-site scripting here, or SQL injection, or eavesdropping on the wire, or unauthorized access. So you're just considering threats. And then you put in the countermeasures, or the countermeasures taken by you. For example, let's lose the mouse. Where is it? Oh yeah, here's it. For example, against unauthorized access, it would be a good idea to use authentication and authorization methods. So you put them in place here. Against eavesdropping, it would be a good idea to use encryption. So you can use a lock here to show that you're encrypting this channel, and you can use really any notation you want. There are no strict rules. It's important that it should be understandable by you and your employees. And what else is a good idea for threat modeling? Trust relationships among components are really important. Trust relationships show you where to set security controls. So for example, in this case here, you get a trust boundary, because there you come to the external users that are communicating with your front end. So there's a change in the trust relationship. So you get a trust boundary here where you take special care of all the inputs. You also got another trust boundary right here in front of the database, because for the database, your whole application looks like one user. So there's a change in the trust relationship, and you have to take special care here. So this is another thing that should be considered when threat modeling. And also, threat modeling is a good baseline for risk management. I know I can fill risk management experts can fill a couple of talks talking about risk management, but it's kind of new to do risk management when designing software or developing software. And you can use such threat model as a baseline for risk management. Risk management in that case is important because it shows you how the risk situation currently of your software is, and you have to know what risk to mitigate and what risks you can accept. Therefore, you have to do some kind of risk management. In other words, it sounds kind of weird, but risk management of software could be important for usability. For example, if the usability of your software is comparable to launching a nuclear missile, nobody will use your software. Except if you're actually working as a developer for a software that should be responsible for a nuclear missile, a certain usability trade-off is justified, I guess. But in such a case, there's another difference, because as a developer of such a software and a human being, I guess you will want that hardly anybody uses your software. But it's just one example what risk management could be good for, to see the trade-off, the usability trade-off you want to achieve. Another thing risk management could be good for is expressing yourself to the management. We often see it that technicians or developers know about security issues, and they report them to the management, but the management isn't willing to take action or spend money on that issue. That's sometimes simply because they don't speak the same language as the technicians. For example, if a tech guy goes to a management person and tells him, yeah, well, there's a problem with our SOAP service, it's accessible from the whole intranet without authentication, the management guy maybe think, yeah, soap, good for washing. So I don't want to bash management, yeah. It's not their main area of competence. It doesn't have to be, it's not their job. But what they're good at is playing with numbers, and they really do understand numbers, especially those with this nice dollar or euro sign attached to it. So if you're expressing yourself to the management, try to break it down to the damage or the impact or something like that, and you will be understood. Yeah. So now you get a basic idea of threat modeling, and just grab the persons responsible at your company or where your consulting services providing and start it. Yeah, you can't do anything wrong. And by starting it, you will see that just by talking with the right persons about security issues, you will improve not only the security, but also the quality of your software and your architecture. So, and it's also a good thing if you're buying security consulting services, because you can show the threat model to your security consultant, and he can say, "Oh, great, you considered this. Have you tested it? No, let's test it." Or maybe he says, "Oh, you haven't considered this. Let's add it. Let's do a few tests." Or maybe just the risk value for this or that is too low, too high. So it is also good for consulting services. Yeah, software review, also good in conjunction with threat modeling. You can do threat modeling during review or review during threat modeling. It's always a good idea to do software reviews. What are the key performance indicators of software reviews? It's number one, experience of the reviewer. Number two is external personnel. So this simply means that they have to look at code they haven't self-produced. And number three, small teams. That are the key performance indicators of reviews. In this book, Modern Software Review, it is said you can find 35% up to 90% of defects during software development by doing regular reviews. I don't know if these facts are true, because it's kind of tricky measuring the effectiveness of reviews. But I can tell you from my own experience, it really pays off doing reviews. So I advise you to do so. And moreover, it's got a good effect on security, and you get know-how and knowledge transfer as well. So couldn't this review done by tools? Partially. The type of vulnerabilities is very important for such comparison, and tools are good for already known technical vulnerabilities, or so-called low-hanging fruits, because they're really, really fast. But they get their problems with complicated and new vulnerabilities, like logical errors, for example. So, and you also have to consider that you have to verify all the output of the tools manually because of false positives. So you always have to measure the effectiveness of check afterwards. And maybe if you're thinking about, logical errors, that couldn't be a big problem. There's this nice story that always reminds me of how big or how large consequences a small logical error could have. But maybe skip that story. It's in short terms, it's about the Cold War, the CIA, and if you want to know more, ask me in the break. So now I want to hand over to my dear colleague, David White.
Okay. Hello, is turned on? Good. It sounded like we were bashing tools earlier. We didn't mean to. Actually, there's some very clever tools out there that do things intelligently, that can really help out getting you started on a complex source code auditing project and helping you get the coverage that your customers want and need. Just as an example of a clever tool that was put out by a research partner of SecConsult, was Pixie. It was developed by the Technical University of Vienna and University of California, Santa Barbara. And it uses mathematical properties of some regular expressions to automatically validate sanitization functions. These are functions that are in the data flow from input through processing to output that ensure that malicious input does not get anywhere dangerous. The short version. The Pixie product is able to validate sanitization functions. It essentially constructs a deterministic regular expression that represents a potential threat. For instance, in SQL injection, a naked quote character. For cross-site scripting, the beginning of a HTML entity with a less than sign. And it expresses the sanitization function similarly, also as a deterministic regular expression. These deterministic regular expressions can be straightforwardly converted into finite state automata, and a transducer, based on these finite state automata, can then be subjected to mathematical analysis. There are some well-developed, fairly robust algorithms implemented in Prolog, which allow you to construct the set of the range of a transducer. And yeah, if you take the intersection of these two sets, if you have the empty set, then you have effective sanitization. And it's math. It works. Another clever tool is also by the same team, well, also by a team associated with the TU Vienna. It's called Whaler, and well, it performs a combination of static and dynamic analysis on Java servlet-based web applications. In essence, a instrumented JVM produces execution traces, which are analyzed by a tool named Daikon. This will generate invariants based on the data from the execution trace. These invariants can then be used to help a static analysis tool find potential logical errors. The result is actually one of the sort of absurd claims that we were lampooning earlier actually becomes somewhat plausible. You can detect some logical errors automatically. Finally, there's something that we developed internally. We support a concept of analyzer modules. These are static analysis tools that run inside the Eclipse framework. This gets you some nice features, essentially for free. Like a useful parser, a project model, meta information about code and projects. And yeah, this means that you do not have to reinvent the wheel or use inadequate tools. You can really concentrate on the analysis algorithms. And the code is actually relatively future-proof if you use stable APIs. And a lot of Eclipse APIs actually are reasonably stable. We're going into a little bit more into that a little bit later. So, the root cause of all of these problems is bad code. Bad code is written by developers. Yeah, sort of do this like Alcoholics Anonymous. Hi, my name's Dave. I write crappy code. Yeah. Typical development environment, well, yes, working with developers and other tools. Typical development environment is a bunch of developers, maybe a bug or almost certainly a bug or issue tracking system, something like Bugzilla or Jira or Track. A source code repository, something that manages the configuration and state of the source code as it's being developed. And in companies that are trying to take security seriously, there probably will be combinations of commercial and free tools used by both testing and QA people and developers themselves to try to identify problems before they get committed and built. Now, the problem is that the communication is inefficient. The testing and QA people can provide the developers with reports. They can talk to them about issues, but at the end of the day, it's hard to really determine whether you have effectively dealt with security issues in your product. What you need is a way to bridge the gap and make sure that problems are communicated to the right people at the right time to make a difference, to implement proactive security and get source code review and auditing into the development process. This star in this diagram represents the Security Code Analysis Framework. This is the software I've been working on for the last 2 years. Security is a collaborative platform that facilitates this communication. It supports the process of implementing proactive security by giving source code auditors a means to integrate both existing and custom scanners with bug tracking and revision control systems used by the developers. Essentially, we play nice with the working environment of developers. A good example of something that we can actually do now is that an issue identified by a tool can be validated and extended by a security professional and turned into a ticket for a bug tracking system, like, as I said, Bugzilla or Jira. And the developers get the benefits of this expertise in a way that doesn't interrupt with or interfere with the way they're used to working. In essence, we are able to kind of transparently get audits done well before code is released and get the information to the right people who can actually respond to and fix the problems. In this way, we facilitate communication between quality assurance and security professionals and development. Now, yeah, so what is it? Well, it's a security workbench. It's an integrated environment for software auditing instead of development. It's built on top of Eclipse, and so we support multiple platforms. Linux and Windows are the officially supported ones. Other platforms are certainly possible. We support a wide variety of programming languages. Pretty much anything Eclipse can handle, we can too. And also a wide variety of development infrastructure. We can pretty much hook up with any source revision control system in use that supports the Eclipse interfaces, as well as any of the supported bug tracking system with a Myelin connector. And furthermore, we have both our own concept of in-process static analysis tools, as well as a interface that lets us integrate third-party tools in both commercial and open source, allowing these tools to provide useful information for developers and auditors. So, in short, oh yeah, and I almost forgot. We also use it to generate really, really attractive reports and wonderful statistics to help management know that their money is actually being spent on something useful. In short, we can do everything. So, yeah, continuing. A unified open analysis platform, collaborative features, monitoring and reporting, and bug tracking integration improves the situational awareness for developers, for auditors, and for management. Everybody knows what's going on. And this actually makes this makes actually dealing with security issues considerably easier and considerably, sorry, brain freeze. It also provides a valuable oversight into complex code auditing projects. So how did we do it? Well, it's pretty simple. It's the workbench itself, the code analysis framework workbench, is an Eclipse plugin. As I said, we can take advantage of all of the nice features that Eclipse has and the support for multiple languages. We have a fairly advanced versioned data store that allows us to have a fairly complete audit trail of work as it's being completed. We have some surprisingly useful visualization features so that, for instance, you can actually do threat modeling in the integrated auditing environment and identify components. We generate wonderful reports, as I may have mentioned. We have open APIs, which means that it's fairly straightforward to extend our product. And offline functionality. You don't need, strictly speaking, to be online all the time. Now, this all talks to the Discoverer server. The Discoverer server implements the real killer feature, which is collaboration. Communication is secured via HTTPS TLS, and actually should be secure over untrusted networks, and provides a kind of instance of record for project progress, as well as enabling. We've had concrete source code audits where we've had auditors in multiple time zones or different continents collaborating with each other over this. It's actually pretty solid. And yeah, this of course brings up the next question: are we open source? Nope. We don't really want to be jerks about it. Actually, we can and will provide the community with demonstration versions of this technology. And I think as even more important, we found the analyzer module concept to be extremely useful. It's very nice to be able to do static analysis without having to reinvent the wheel. And, doing something like RATS does, where you have a fairly primitive lexer trying to understand C++ code. RATS ends up actually getting a lot of stuff wrong. Something you can do with Eclipse and CDT is you have a real parser, a real C preprocessor. It understands things like macro expansions. It understands things like aliased functions. It can compare types. It just makes it a lot easier to work better with static analysis if you don't have to write your own tools all the time. And we're hoping that, or we've actually are concretely planning at some point in the future to provide an open source framework which will support the same analyzer module interface that we use internally. The benefits would be then that we would not only be able to provide some of the technologies we've developed to the community, but we can also work with the community and with, for instance, academic institutions, save grad students a lot of work and let them concentrate on coming up with new and clever approaches to understanding source code. And yeah. So, in short, we have a wonderful platform that can do everything. Well, not quite, but it does address a lot of concrete and practical needs that arise when auditing. We can distribute work among our consultants, or among our auditors. We have better channels to communicate and cooperate with our customers and really help them out and really help them out and help eliminate problems before they arise. We have ways of essentially taking advanced technologies from academic and research projects and applying them to real concrete issues in real concrete products that are being developed by our customers. And yeah, we support and automate the process of implementing secure software. Do you have any?
Yeah, so to sum it up, keep in mind that software security is just a subset of software quality, and that secure code reviews and audits can increase both security and the quality of your products. And the thing is, these tools can help you, but you can't replace humans in such a complex scenario completely by tools. You always have to have someone that really checks the results and that do manual verification. And of course you have to have someone that really corrects and fixes the issues. And maybe it would be a good idea to help those people while they are doing this. So,
Really, if I may, But the really important issue is it does boil down to communication and providing a meaningful context to evaluate and share findings as they come up, and communicate with the right people at the right time.
Thanks for your attention. Any questions?
Yeah, thanks for your patience. Yeah.
How well does it scale? And let me explain what I mean by scale. So hundreds of projects with millions of lines per project with thousands of developers.
What do you mean actually the automated parsing and analysis?
Well, actually, using the system with thousands of people over hundreds of projects with very large projects.
I hand over to the lead developer.
Okay, actually, doesn't look so bad. We've had some very large projects on the order of, I think, million lines of code. Some things maybe have taken a while, but the way that we work, we generally do not worry about throwing around the customer's code. We instead do an initial static analysis and construct a kind of coordinate system over the code. This means that the amounts of data that we're pushing through the server is not as big as is not as much data as you'd think. So yeah, we scale pretty well.
And then when you say you integrate with third-party analysis tools, so you import their traceback data, so as you're analyzing the issues, you can sort of follow it through in the IDE as opposed to using their interface?
Yes, actually.
And how does it work with their licensing things? Because I know some of them really want you to go through their UI because that's the only way their license servers get hit.
Okay, no, I think I understand. I think I misunderstood you a little bit. For a lot of these products, there is usually a way of doing things that is within the licensing agreement of the vendor. For instance, an entirely plausible way of getting something into our system would be to take a generated report, run an XSLT over it, turn it into our import format, and Bob's your uncle. It's taken care of.
All right, thanks.
Hi. You mentioned the possibility of automatic detection of logical flaws. Can you provide any example of that?
Yeah, that was part of the research project we're currently working on with the Technical University of Vienna. Yeah, you always have to consider that it's possible in some cases. So what the Technical University of Vienna does in such a case, they provide a modified version of the Java virtual machine, and they're basically analyzing the control flow of the software, so they're learning how the software works, and then they are monitoring the software during runtime and feeding the software with test data, and then they can see some kind of, or maybe they can guess where logical vulnerabilities may occur. It's always the matter of how concrete the results, how concrete you want the results. It's possible in some cases, so there is no universal way. Okay. He wants to say also something.
Yeah. In the paper describing Whaler, concretely they discover automatically an authentication bypass vulnerability. So yeah, a real world vulnerability in, I believe, a open source Java servlet based web app.
So manual testing for logical vulnerabilities won't be, will still be required, so don't worry. Any other questions?
We can provide you with the paper if you really want to read it.
Yeah, I guess there are no questions left. Every time, maybe I can tell the story now. Okay. Do you want it? to anybody who wants to hear the story about logical vulnerabilities? Okay, yeah, sorry, tell it. During the Cold War, about I guess in 1982, the Soviets want to build a pipeline somewhere in Siberia, but of course they haven't had the technology and the software yet, so they tried to steal it from the US. But the thing is this, that the CIA noticed that and was able to modify the software before they fell into the hands of the Soviets. So the result was that there was a small logical error in the software that produced a wave in the whole pipeline system while it was running, and the result was a big explosion that was even visible from space. And that's really a case where the description logical bomb really deserves the name. Yeah. And so small errors and small logical vulnerabilities can even have big consequences. So always remember that. Thank you very much. I guess we're done.